Hey there, here we go into, well, integrating with parametric equations, which is actually no different than integrating with other kinds of equations. So let's jump into this and see that we've actually done these problems many times before. You'll see what I mean right now. Given the derivatives of the parametric equation x of t, y of t, are x prime of t equals 6t cubed, y prime of t equals 7t plus 1, and I'm giving you that x of 0 equals 6. What that means is at time t equals 0, the x value is 6 of a point, and at time t equals 0, the y value, or the y coordinate of a point is 2. So in other words, you get the point 6 comma 2. Find the point on the graph of x of t, y of t when t equals 2. So essentially, I've given you the velocity functions in the x direction and the y direction, and you're asked to find and go backwards one step by integrating to find the position at t equals 2. It's not as bad as it might seem. We basically split this up into two pieces. So we know that the integral from 0, which is the value that we have, to the value we want, 2, of x prime of t dt is equal to x of 2 minus x of 0, a little fundamental theorem of calculus right there. So going off from here, we would have that x of 0 plus the integral from 0 to 2 of x prime of t is 6t cubed dt would give us x of 2. That would give us our value. It's just adding x of 0 to both sides. And so x of 0 is equal to 6, nice, plus the integral of 6t cubed, well, that's going to be t to the 4th over 4, and then don't forget about the 6 that was hanging out there, evaluated from 0 to 2. Now be very careful here. We're not evaluating the 6 in that. We're just evaluating this part from 0 to 2, and then adding 6 after the fact. So that's 6 plus, when I plug 2 into this, 2 to the 4th is going to be 16. So you're getting 2 times 16, that's 2 to the 4th over 4. And then when we plug in 0, that'll be minus, well, 0. It's the fundamental theorem part. And so when we simplify this down, this will be 6 plus 16 divided by 4 is 4, times that remaining 6 is 24. And so that's equal to 30. So this is x of 2. So that means the position of the x-coordinate position, I should say, is 30 at time t equals 2. So on now to a very similar idea. We would have the integral from 0 to 2, but this time of y prime. We're going to find the y-coordinate of t is equal to the difference between the y-coordinate at time 2 and the y-coordinate at time 0. So just taking it piece by piece, that's all. We split it into parts. So similar to last problem, we'd have y of 0 plus the integral from 0 to 2 of, well, y prime of t is 7t plus 1 dt. And that would equal to y of 2. Okay, so let's solve. Y of 0 is the initial y value, that's 2, plus the integral. Well, that's going to be 7 halves t squared plus t. And that right there is evaluated from 0 to 2. And again, that's just this component right here. And that's going to give us y of 2. So it'll be 2 plus 2 squared is 4 times 7 is 28 divided by 2. We plug that in, plus 2. And then that's going to be minus 0. 0 squared is 0 plus 0 is 0. Nice. So when we simplify all this down, that's 2 plus 14, 28 divided by 2, plus 2. And that's going to be equal to 18, which is y of 2. So now we have x of 2 and y of 2. So our final value is, it's the point 30, comma 18. Our x value is 30, our y value is 18. Boo-yah. So the moral of the story? Integrating is no different. You split it into two different pieces. How we're moving left and right, how we're moving up and down. It's the story of the day, or days, as you study parametric equations. Peace.